In this lesson, you're going to see that we're going to look at nets, not fishing nets or butterfly nets, but mathematical nets, and then we're going to look at surface area. So the first thing I want to look at is we're going to take our three-dimensional figures that we talked about the other day, and in this one I just want to draw a picture of it. So it says sketch a corner view of a rectangular prism. Well, we got to think back to what a rectangular prism is. It's a three-dimensional figure where the bases are going to be parallel and congruent, and in this case, being it's a rectangular prism, the bases are going to be rectangles. And it gives me the dimensions of this. So really, if you're going to visualize it, I think of maybe a shoebox. It could be something like this, where it would be 3 units by 4 units by 6 units. I'm going to try to draw that shoebox on, this is called isometric dot paper, and it makes it nice because you can kind of draw a perspective drawing, but what's nice about this, in a perspective drawing, things that get farther away from you get smaller, but when we draw it this way, things that are congruent in the actual figure are going to look congruent on our paper because they're not going to get smaller as they move farther away. Now the way you want to start this is pick a side length. Now I'm going to go with the 3. I'm going to call that my high, so I'm going to start there. And I want to start it towards the bottom of my paper, and I need to make a segment that's going to be approximate, or not approximate, it will be 3 units long, and I can use my dots to do that. So we'll start here, and I'm going to go up 1, 2, 3. So I have my height. Then I'm going to go to my 6 units long. So I'm going to go to the very bottom of that segment, and I'm going to head in this direction 6 units. 1, 2, 3, 4, 5, 6. And then I'm going to go to 4 units the other way, so that's going to be 1, 2, 3, and 4. There's the basic structure of my box. Now it's to finish it. Things that are parallel in real life will be parallel in my drawing. Not like a perspective drawing where things get smaller as they go away. So I'm going to go with the verticals. From here I'm going to have a segment that's going to go up 3. Notice it's parallel to the other one. That's why the dot paper is nice, because it makes sure that things are parallel. There's that one. Well, now I can kind of connect the dots. So now you're seeing one of the faces of my rectangular prism. You see another one. Now it's just a matter of putting on what I would call the top in this case. Well, this is going to have to be that same 4 units long. This will be 6 units long. And right there I have the isometric drawing of a 3 by 4 by 6 rectangular prism. Now that's using the landscape style on the isometric dot paper. You could also do it using going portrait style. It's not going to be any different. It's going to look a little different just because it's going to get a little bit bigger. And I'm going to start here again. I'm going to go my 3, so now it's 1, 2, there's 3 units. Now when you go back your 6, don't go to this point, you're going to head this way. And the reason you do that is because you want the units to be equal. Now when you look at that, that's 1 unit and that's 1 unit, and they're equal in length. So I've gone 1, I need to go 2, 3, 4, 5, and 6. And if I head back the other way for the 4, 1, 2, 3, and 4. I'm going to go up my 3 from here, go up my 3 from here, head down, basically doing the same thing that I did in the other method, or on the landscape. And now I'm just using the portrait. 1, 2, 3, 4, 5, and 6, and then I should be able to just connect. And there you go. So it looks bigger in the portrait style, but it's still that exact same rectangular prism. Now the next thing I want to do is get into the nets. Now remember I told you that a net's not a fishing net or your butterfly net or your little bug net, whatever you want to think of. It's a 2-dimensional figure that can be folded into a 3-dimensional figure. Or think of it the other way, take my 3-dimensional figure and unfold it. I go back to maybe the shoe box, or I like the cereal box. If you undo a cereal box, for the most part that's a net. Now there's some overlapping in the cereal box to help keep it together. When we look at our nets, we're not going to have any overlaps. We're just going to, places that butt up are just going to match up and we're going to go with it. We're not going to have to worry about any tabs to glue or anything. So I want to take those figures, that box that I have right there, and I want to be able to draw the net. Now my recommendation is just pick one of the faces to start with, and it doesn't matter. Now I'm going to go with and start with that very big face, the rectangle that would be a 6 by 4. Now I've already pre-made these, but had I not pre-made them, I'd just draw them. So I'm going to take my 4 by 6, and I'm going to start there, and I would draw a 4 by 6 rectangle on this dot paper, and it's going to match up, and And there you go. So what's nice about the dot paper. Then I think about this. As I roll around my prism, I'm going to now go to this one. I already have this one in there. It's been drawn on. Now I'm going to kind of go around that box. The green one would be the next one. Well, that's a 6 by 3. So I already have the edge that's 6 long. So my rectangle that's going to be a 6 by 3, I just need to have it butt up next to it. I draw a 6 by 3, use the dots, and I have it. Well, then as I continue to go around, now it would be the bottom, which you don't see on this figure. Well, the bottom is going to be congruent to the top, which was a 6 by 4. So I need to put another 6 by 4, which would be just like this one. I'm going to just clone this one, and then I can bring it down here, and I can draw it on. You could just draw it on yourself. Come back to this one. So that was just the bottom that I did, and then I have kind of that back or the right face. That would be another one that would be just like this one. It's a 3 by 6, so I can clone this one and bring that down. Now I think of that as that's all the ones that kind of wrap around that rectangular prism. Now it would just be to put on, you want to think of it as the front, or maybe that's the right, and then there's one in the back that's congruent to it. Well, when I come over here, I know that those are attached, or it touches a side that's 4 and a side that's 3. It's a 3 by 4 rectangle. I'm going to bring out my 3 by 4 rectangle, and I just have to attach it here. I look at this and go, well, I can't put it here because that doesn't match up. The side that's 4 doesn't match up with the side that's 3 of this one, so I'd have to come up here. So there's one of them. Now the other one's going to go on the other side of my net. Hold it. I didn't have anything highlighted. Let's try that again. There we go. I can bring it over here, and I can put it here. I can put it down here. A lot of places I could put it. I could also put it right here. It's still a 4 by 3 or a 3 by 4, however you want to look at it. So there's lots and lots of places you can put it. And this is not the only way to draw the net. You know, as I showed you, you can bring this down and that'd be another net, so on. I'm just going to leave mine like this. But again, many, many ways to draw the net for a rectangular prism. There's one of them. Now the next thing I want to talk about is surface area. And I'm hoping that just the word surface area gives it away. It's the area of the entire surface of that three-dimensional figure. So what I want to do is I want to find the surface area of that previous prism, the one that was the 3 by 4 by 6. Well, I come back here now and I go, well, if I have the net drawn, the net is nothing more than the surface just flattened out. I have to find the area of it. And now I look at this net and I go, well, this is going to be pretty easy for me to calculate the areas. It's a bunch of rectangles. I can just do base times height for all of them. So this first one up here, it's a 6 by 4. So 6 times 4, area of that rectangle is 24. Well, I know this one's congruent to it, so that one has an area of 24. I don't really have to do a whole lot of work for that one. If you come here to the next one down, well, now this one's a 6 by 3. That's going to have an area of 18. And then the rectangle that's down here, that's congruent to it, so I know it has an area of 18. And then last but not least, I have the two rectangles on the left and the right. This one's a 3 by 4, area of 12. Before this one has an area of 12. Now if I want the area of the entire thing, I just have to add up all these numbers. I have a 12 and a 12. And I have the two 24s. And I have the two 18s. Do a little addition. And I'm going to have my grand total. Now, since I don't have a calculator, I'm going to try to do a little mental math here, and I'm just going to pair this and this up. That gives me 30. That gives me 30. So now I'm at 60. Then I have 60 plus the 24 and the 24. If I go 20 and 20, that's another 40. So now I'm at 100. Then I still have the two 4s and the 20s. So I'd be at an area of 108. And being I didn't have a label, it'd be units squared. And it actually said each side length was 3 units, 4 units, and 6 units. I just found the surface area of my prism by first pulling it apart into a net and then finding the area of all the little pieces and adding them together. Now this one, I want to find the surface area of this one as well. So my suggestion is, and as it says in the problem, it says draw the net. And even if it doesn't say draw the net, I would more than likely draw the net to find the surface area of it. So what I'm going to do is, I'm going to start with this rectangle here on this triangular prism that I know the lengths of. It's a 13 by 8. I don't have to have the dot paper. The dot paper is nice, but not necessary all the time. Here's my 13. Here's my 8. Now, if you don't have dot paper, you definitely want to put your lengths on there so you know how long each one is. Now, the next thing I would do is I'm going to roll around to the bottom piece here, and I'm going to put that rectangle in. Now, I look at this and go, well, I know one side is 8, but I don't know how long this edge is. It doesn't tell me. So then I can't really draw it in here and put labels if I don't know the length of it. So what I'm going to have to do is I'm going to have to figure out how long is that thing. And what I can do is, I'm going to look right here. This is a right triangle. I know hypotenuse is 13. I know one of the legs is 5. I can do the Pythagorean theorem and figure that out. Here's my a squared plus b squared equal to c squared. It's 25. That's 169. Let's get rid of the 25 from both sides. Now I have b squared equal to 144. If I take the square root of both sides, b is going to equal technically a plus or minus 12, but being we're dealing with the lengths of sides, we don't have to worry about the negative in there. So I know this side, I'll put it right here, is 12. When I come back now and want to draw that rectangle that's 8 by 12, oh, that's not the piece I want to move. I want to take this and move it up a little bit here, like there. I can put that rectangle on, and again, it's a 12 by 8, which I shouldn't have moved this, I should have left it here, because I have to attach it to the right place. If it's a 12 by 8, I have to have the 8s match up, and I will go right here. There's my 12. You know, the last one that I did, I put it down here, but one of the edges of that green rectangle is not 13 units long, so it wouldn't make sense to put that there. Alright, then I'm going to continue and move around. I'm going to get to this rectangle here. I know that one is a 5 by 8. Well, being I don't have any more room to go to the right, I can come back to my red rectangle. It's touching that one as well up here. So I can attach it to the other side. It's a 5 by 8. I know that one side of that rectangle is 8. This one's the 8. So I have the 3 rectangles that are wrapping around. Now it's just a matter of putting on the 2 triangles that kind of look like they're in the front and the back. And technically you can put it anywhere on any one of these edges. You can put it here, you can put it here, you can put it here. Now I like to put it on either the 5 or the 12 because the 5 edge and the 12 edge come together to make a right angle. It's just a little easier to make those right angles off of there versus trying to make your triangle off this 13, and then the right angle actually has to be out here somewhere. Actually, it'd be over here somewhere. So I'm not going to put it there. I'm going to put it off I'm going to go with the 12. So being my rectangle as the 12 side, I already have that. I'm going to let's just do the back one. So I have the 12 here, and then the 5 is going to have to come here so that I get that right angle. And then that's going to make this part right here the 13. Then the other one, I could just put it right here. There's that 5 again. There's the 13. Put my 5 in there. I could have also come over and I could have put it here. Now realize that if I put it off to the left, then this edge here has to be the 12, and then there's the 13. So it doesn't matter. You can either put it here or you can put it here. Take your pick. I'm going to go with this one. It looks like I have a little flying spaceship or something. So I have my net all drawn, all marked up. The other part of this was find the surface area of it. Well, find the area of each piece, and we're going to have it. I'm going to start with my blue rectangle, 5 by 8. 5 times 4 is 40. I'm going to go to my red rectangle. Well, that's 8 by 13. Multiply those together, and I'm going to get 104. Move move on to my green rectangle. That one's 8 by 12. That's 96. Then I have my two triangles. Now I have 1/2 times base. Well, the base of my triangles, I could go with 12 or 5, it doesn't matter. I'll go with 12, and then 12 is the base, and 5 is the height. That's going to give me a total area of 30. I have one more triangle congruent to it, so that's 30. Add all those up. Now in this case, I'd start with 30 plus 30 is 60. I'd add the 40, now I'm at 100. If I take 100 from there, now I'm at 200. If I take the 96 and the 4 that was left over, there's another 100. So grand total of 300. Now did I have a label on these? No, just units, so I'd go with units squared. Could have been inches. I'd have been called 300 inches squared. So the surface area of my figure comes out to be 300 units squared. And remember, what I did is I drew the net, and then I found the area of all the little pieces. And there's multiple ways to find the area of those pieces. I don't have to do all three of these rectangles. Somebody may have noticed that, well, Mr. Rude, why don't you just do or find the area of one of those, one big rectangle instead of three little ones? You could have found the area of, yes, this one big rectangle, and then added on the two triangles. You're still going to end up with the same surface area. So take your pick. My last slide, I'm going to talk about prisms. Talked about them a little bit yesterday, but now specific types of prism. One is the right prism, and notice that in a right prism, the base and the lateral faces are perpendicular. So if I come down here and I look at this prism that I have drawn, that would tell you that the angle that that green base is making with this lateral face is a right angle there. Same thing with the back base and the lateral face. They're going to make right angles. And then if you go to the oblique prism, well, instead of those bases and lateral faces making 90-degree angles, they're not going to make 90-degree angles. They're not going to be perpendicular. Most of the prisms I will say that we're going to work with are going to be right prisms, but they all won't be. We'll have a few of the oblique prisms in there as well. Then talking pieces, well, the base, I did this color coordinated, so you can see that the pentagon in this one is the base, like we talked about yesterday. And then all the rectangles in this one are lateral faces. Now, what you need to remember is sometimes these lateral faces are rectangles. In a right prism they will be, but if you go to the oblique prism, then the vast majority of them are just going to be ordinary parallelograms. And then the lateral edges down here, let me get rid of that black so we can actually see it. The lateral edges are all the edges that run in between the two bases. And the reason I talk about lateral faces and lateral edges is because sometimes you're going to be asked to calculate lateral area. Not really any different than surface area, other than don't include the areas of the two bases. In this case, it would be find the area of the 5 parallelograms, or the 5 rectangles, depending on what they are. And that's going to conclude my lesson on nets and prisms and surface area.